Hi everyone, my name is Nuruddin and we have here with me my student Matthew Tan.
Hello everyone.
Welcome back to A207 Data Communications and Networking. We are now at Chapter 2 where we start looking into the principles of networking. Chapter 2, the OSI Model. There are two learning objectives of Chapter 2. First, we shall explore the OSI model, and next, we shall take a deeper look into the OSI model and try to understand its 7 layers and their functions. Imagine a situation where two people are tied and blindfolded in a large room, and their job is to send a list of messages to each other. Sounds impossible? That is exactly what computers face in a network.
So how do humans solve this?
Well, they come up with an agreement, a set of working rules. Someone will have to speak at a certain time and they will have to signal to indicate that they want to speak. They also need a signal for the end of their speech, which will allow others the chance to start talking. Obviously, if everyone speaks at once, nothing can be heard. This shows clearly just how important this set of rules really is, and in a classroom we observe the rules by keeping silent as the teacher speaks. We raise our hand to show that we wish to speak, ask a question, or give an answer. This set of rules applies to machines equally and is called a protocol. As communications and the messages to be delivered get more complex.
What do you mean by complex communications?
Two-way interactive communications being an example of complex communications. Obviously, just one set of protocols will not adequately cover every aspect of a communication stream. Having more than one set of rules is now a common occurrence and is called protocol layering. Humans communicate interactively, and thus for machines to do the same, we need to apply principles of human communication protocols to govern machine communications. And data communications and networking depend on layers of protocols to work seamlessly with each other in real time. An international standard was introduced to combine and govern multiple layers of protocols into what we call a communication stack. This stack is thus a layered sandwich with sets of rules making up each layer, and each layer in the stack represents a distinct segment needed in machine-to-machine communications. The OSI model contains 7 distinct layers. Starting from the physical layer 1, OSI moves to software communications at layer 4 and finally ends with application-to-application communications at layer 7. Each layer defines the type of media. Note that layers 1 to 3 are physical layers and layers 4 to 7 are software, and how they send and receive data.
Do we have to memorize the OSI model?
Yes, you do. OSI sits at the heart of a network specialist's skill set. In theory, OSI represents an ideal data communications model, but in practice a similar but more streamlined model called TCPIP is used. TCPIP reaches across all present network architecture in use today and sits at the heart of almost all networks presently in use. In this diagram, TCP and OSI have distinct and clear parallels. Do remember that the TCP part of TCPIP sits at layer 4 of OSI and is called the transport layer in both protocols.
How about equipment such as switches and routers?
Switches are layer 2 devices and routers are layer 3 devices with different roles. In your bachelor's degree course, you'll go on to learn how switches can function as layer 2 and layer 3 devices at the same time. OSI was an international initiative, but in practice, unfortunately, it was overtaken by the more agile TCPIP, which is now the de facto network protocol stack in use across the world. The short history of TCPIP is, it was developed and introduced in the USA as the communication protocol of the DoD. One day, the DoD made the decision that all DoD bases, computers, networks, and the vendor computers as well, were required to use TCPIP as a common communication protocol. Since TCPIP represented a wide-scale communications standard which was proven in the field, adoption came naturally and far more easily than OSI, which was bogged down with lengthy meetings. Next, data communications from other countries with the USA started following the TCPIP protocol as well. And that, in a nutshell, was how TCP/IP overtook OSI and became the international standard we use today. This ends our discussion on Chapter 2 of A207 Data Communications and Networking. Remember to post any questions onto Google Classroom. Work hard, work smart, work your way to your dreams.